blood. Because that is going to mean so much. Even when we start talking about osteoporosis, right? Or parathyroid hormone. And we talk about calcium. Because if you increase calcium in the blood, what happens to your bones? Right. You decrease the calcium in the bones, and the bones become more brittle. Does that make sense to everybody? Yes. Okay. All right. So now let's keep going. Let's see if we make sure we understand this. So now, say for instance, we're increasing the glycogen, right? That makes sense, right? So we're storing the glycogen. So we're increasing glycogen, which you said that if we increase glycogen, that means that we're decreasing blood glucose, right? But if we decrease blood glucose, we might need some blood glucose, right? So we need some. So in order to get the blood glucose, what do we need to do to the glycogen? What do we need to do? Break it down. Good, Andy. Perfect. Exactly. So that means that we need to break these bonds between the glycogen, right? Well, not glycolysis, Prathima. Glycolysis is breaking down the glucose. This is breaking down glycogen. So we actually call this glycogenolysis, not glycolysis, but it's called glycogenolysis. Does that make sense, Prathima? You got it? Okay, perfect. Now, what if we could not break down, or what if something was wrong with the enzyme that breaks the glycogen down? What would happen? Right, but what would happen though? Like, give me what do you think I would expect to see? Glycogen is the storage form of glucose, right? But if we did not have the enzymes that could break good, Andy, that's right. Andy is right on it. You're going to increase the amount of glycogen. Does that make sense? Because if you can't break the glycogen down, then you're going to increase the amount of glycogen. Now, what is going to happen to the liver as a result of that? That's right, Amira. Hypoglycemia, hepatomegaly. Good, Celine. That's exactly right. So Celine said it. Hepatomegaly. Oh. So that means that all of your glycogen, watch this, glycogen storage diseases. Every glycogen storage disease you have is because you cannot break, or you're missing an enzyme that can break down glycogen. Does everybody follow me? Everybody understand that? So that means then every single glycogen storage disease, one of the symptoms, right, one of the signs is hepatomegaly and hypoglycemia. That makes sense. Everybody with me? Okay, everybody got that? Well, you may not believe me, right? I don't think y'all believe me yet. You don't believe me, so I got to prove it, right? That's okay. I don't mind proving it. Let's take a look at this. So I came up with this mnemonic, right? Called Very Hot Camp. You ever heard of this? Anybody heard of this mnemonic? Very Hot Camp. Okay? Now let's take a look at it. Let me see if there we go. So as soon as I get here. Okay, here's the V. Here's my H. And all of the camp. Okay, everybody see that? So each one of those, and I said, well, very hot camp, glycogen storage. So as soon as you think of glycogen storage, I want you to think of glycogen as the storage form of glucose, your sugar. Why do you store it? Because you may need energy later. Why do you need energy later? if you are at a very hot camp. I know it's corny, probably don't make a lot of sense, but at least you remember it, right? Okay. All right. So that's the way you remember the mnemonic. Very hot camp. Now watch this. The V is for von Gerkes. That's the name of the V, the von Gerkes. Look here. Von Gerkes has the letter G in it at the end, the von Gerke. That G, I always like to think of glucose. So now I know that von Gerkes, the problem is a problem with glucose 6-phosphatase. So on a multiple choice test, and I see Gerkes, all I'm looking for is something with glucose. Everybody follow me? And I keep moving. Okay, now watch this. Now, the H in hot is for HER's disease, H-E-R. When I think of HER, H-E-R, the problem is a phosphorylase. Okay? The problem is a phosphorylase. I'll tell you that in just a second. Follow me here. Now, the next thing is called A, B, C, D. Everybody knows their ABCs, right? A, B, C, D. Y'all see A, B, C, D? Anderson is a problem with the branching enzyme. Corey is a problem with the debranching enzyme. Ah, do y'all see that? So A, B, C, D. Everybody understand that? Everybody get it? Tell me yes or no. Okay, Kayla says no. Okay, problem. Good, perfect. I like when you say no, because that helps me do it. Watch this. So, you remember when we said that every glycogen storage disease is due to an enzyme deficiency, right? So watch this. The Anderson glycogen storage disease, this one right here, Anderson, the problem with Anderson is that they have a problem with what we call the glycogen branching enzyme. That's the enzyme. That's the name of it. It's called glycogen branching enzyme. The problem with Corey disease, it's a glycogen storage disease, but Corey's is due to the glycogen debranching enzyme. You follow me so far? You with me? Okay. So the mnemonic, the way we remember that, is A, B, C, D. Anderson, the problem is branching. Corey, the problem is the debranching enzyme. Does that make sense now? Everybody understand that now? Okay, Kayla says yes. Okay, good. Pratima, good. Okay, Ruby, you got it, Ruby? Karina, yes. Celine, yes. Ruby, no. Okay, Ruby, do you have a microphone? You have a microphone, Ruby? Okay, go ahead and turn your microphone on, because sometimes it's easier when I can ask you, and then I can see exactly what you're missing. Just turn it on real quick.
Yes, Doctor.
And it should turn green at the top. Okay, I can hear you.
It's green. So Dr.
Can you hear me?
Yeah.
Okay, so tell me which one you're having problems with. Hello? Can you hear me? Okay, so I'll just go through and I'll just say this again. So the mnemonic, so Corey's disease, the problem is with debranching enzyme. That's the enzyme deficiency. Okay? The problem with Anderson is the branching enzyme deficiency. Those are the deficiencies that cause these diseases. Okay? All right. Can you hear me, Ruby? All right. All right. So let's look at the next one. The next one is called McCardell's. This is probably the easiest one because McCardell starts with the letter M, right? M. So guess what? The problem with McCardell's is a problem with muscle phosphorylase. When you say branching, you mean the link. Exactly, Jessica. That's right. When we say branching, we mean the linkage, how they're linking. Very good. Do we need to know the characters? No. That's a good question. The answer is no, Stan. The answer, what they would ask you if they ask you anything is they're going to ask you about basically the enzyme deficiency. They're not the characteristics. The only one that they really would ask about characteristics for is McCardell's. And the only reason why is McCardell's will give you like proteins in your urine. So with McCardell's, you'll get this myoglobinuria, right? So you'll get like proteins and things in the urine. That's the only difference, okay? But all of them will give you hepatomegaly. Now, here's what I would tell you to do. The easiest ones you can remember. The other ones you get by process of elimination. So if I asked you all, what are the easiest glycogen storage diseases you can remember and their enzymes, which ones would you tell me are the easiest for you to remember? Which ones would you all say? Okay. Andy says VGD, Von Gerke's, the ABCD. Gotcha. Corey's, the branching. Okay, gotcha. Okay, perfect. Exactly. Right. So, okay. So basically the easiest ones that most people can see is McCardell's is easy, Anderson, Corey, Von Gerke, right? So that means if you knew 4, right, out of the 6, could you eliminate the other 2 in an answer choice? If you saw it in an answer choice. Does that make sense to everybody? Yes. Okay. Now, that brings me to a very good point. The way you do well on this exam, the way you pass the NBDE, and trust me, I've been doing this since 2009 with over 500 foreign trained dentists who've already taken the class and U.S. trained dentists who've taken this class. The same process applies. It's not about if you know all the right answers. It is your ability to eliminate wrong answers. Does everybody follow me? So you don't have to learn everything. You just need to know what you know well. Okay? And I'm going to teach you how to do that throughout this course. Okay? All right. So is everybody good with this? Everybody good? Sounds nice? All right, let's keep moving. Now watch this. This next one is inulin, and I'm going to put this over on the whiteboard. How many of you have heard of inulin before? This is a favorite on the test. Inulin. They like this one, right? All right. What is inulin? What is inulin? Good. Karina says it measures GFR. What else is inulin? Good, Andy. That's right. Andy is all, that's right. It's a polymer of fructose. No doubt about it, right? It's definitely a polymer of fructose. And we use it to measure GFR. Good, Stan. Now, watch this right here. I'm going to put up a formula. And I want you to tell me what this formula means. All right, let's see here. Let's see. Let's do. Oh, you're jumping ahead, Karina. I haven't even got to that yet. Urine flow times urine concentration all over plasma flow, right? Plasma concentration. Now, as soon as I put this formula up here, and I put, I'm going to put a variable as a B, I'm going to put a B right here. A B can mean anything, right? What is this the formula for? Can anybody tell me what this formula is for? I got you all. No. No, it's not. Not GFR. I know what you were thinking. And I told you B equals any substance, any substance. So B means any substance. So what is this formula for? Anybody know this? Oh, go ahead, Sakshi. Look at Sakshi. Good job, Sakshi. That's right. It's the formula for clearance. Exactly. Perfect. Exactly. Okay, everybody see that? Now, what she said, though, was when Sakshi said, okay, that's the formula for clearance, right? That formula really does look like the formula for GFR, doesn't it? Except all we do is replace inulin, right? The urine flow of inulin times the urine concentration of inulin over the plasma, right? Concentration of inulin. So now, just by changing inulin and using inulin, that's what it is. Oh, okay. Stan is asking, okay, what is clearance? Okay. So Stan, you remember I told you, Stan, what are the two places in your body? What are my two places, Stan? Good. In the blood. That's one place. Or outside the blood. Okay, gotcha. Clearance, Stan, is when you urinate. If you get rid of something, if something leaves the body, you're clearing it from the body, right? So as you clear it from the body, that means that it's less of it there. So look at this, Stan. If I increase the plasma concentration of morphine, let's use morphine, right? If I increase the plasma concentration of morphine, and as a matter of fact, I just taught this tonight to our NBDE students. We were doing pharmacology tonight. If I increase the plasma concentration of morphine, what happens, Stan, to the clearance of morphine? That's right. Exactly. Does that make sense? Because if it's more morphine in the blood, then there's less morphine that's being urinated out. Does that make sense? So that's what clearance is, just its ability to leave the body. Okay? So GFR, the best measure of GFR is inulin. Okay, good. Now, is inulin the only measure of GFR? Is that the only way we can measure GFR? Yes, good, Sakshi. That's right. Creatinine, okay? Good. But if they ask you what's the best measure of GFR, the best measure, which one are you going to pick? Yes, thank you. You're going to pick this one right here if they ask you the best measure, okay? Outstanding, okay? Now, is this all making sense to everybody? Is everybody following? You're good. Okay, perfect. Now, let me tell you something. When I thought about these, so the reason I put these glycosaminoglycans together is because people would take the test, they would come back and say, Dr. Sutton, I had this on my test and I didn't know how to answer it, or I didn't know there's so many of these glycosaminoglycans and they confuse me. I said, okay, well, let me see if I can figure out a simple way to answer these questions. First of all, does everybody know what a glycosaminoglycan is? Do you all know what that is? Okay. All right. No problem, Satara. All right, Pedro, I got you. Watch this. Here's the easiest way to think about it. If you were putting up a house, right? If you were building a house, and you know how you lay the foundation and then you put the beams, the wood beams up to kind of hold the frame together? A glycosaminoglycan is a frame. It's a structural component, right? So basically it's used as a structural component throughout the body. Does that make sense? That's the easiest way to remember it. Now, what they're going to ask you on the test, though, is about the different glycosaminoglycans. Like, what's unique about each one? So here we go. Hyaluronic acid. High, I have no sulfur. High, I have no sulfur. I know that sounds crazy, but that's the way you remember hyaluronic acid, because it does not contain sulfur. High, I have no sulfur. Everybody got that? All right, watch number 2. Okay, chondroitin. You see that C, the letter C in chondroitin? That C means it covers everything. So if I say it covers everything, that means it's the most abundant. Yes, that's right, Stan. That's correct. So chondroitin is the most abundant glycosaminoglycan. Everybody follow me there? That makes sense. So far, so good. Okay, watch this. Watch the next one. The next one is called heparan. Not heparin, but heparan. R-A-N. Heparan. Now watch this. The only way you can remember, well, I came up with this one going back to my childhood. When I was a little boy, you know how you have the basement at the house? You know, you have your house and you have the basement. My mother would cook this liver. I used to hate liver. You know what I mean? You know how people would cook liver? And my mother would try to make me eat this liver, and I hated it. So what I would do is when she turned, I would put the liver away, and then when I had a chance, I would run. You see, I ran down to the basement, right? And I hid the liver in the basement, right? Now, that means that heparan is the major glycosaminoglycan that we find in the basement membrane. So in your basement membranes, you're typically going to find more heparan sulfate. Does everybody understand that one? Everybody got it? Okay, perfect. Okay, now watch this next one. Heparin is not ran. That's just the anticoagulant. Okay, it's just the anticoagulant. Okay, good, Satara. Satara, you can remember that, huh? All right, so heparin is just an anticoagulant. Okay, that's the one we use to dissolve clots. Now, anytime you see the word derm or keratin, what automatically comes to your mind? Derm, keratin, what do you